Have you ever had the thrill of riding on a spinning Ferris wheel? Maybe you've enjoyed riding on a horse. Or perhaps you've had the unpleasant experience of getting car sick. Maybe you've had the experience of flying in a plane. Or perhaps you've ice skated on a frozen pond. Or caught a ball. What do all these things have in common? That's right, they all involve moving things. During the next few minutes, we're going to take a look at how and why objects move as we explore things in motion. How do you know something has moved? You know something has moved because its location or position has changed. For example, you know this deer moved because it's in a new position. The reason you know something has changed its position is because the objects around it do not move. You can tell these vehicles are moving because the buildings behind them are not moving. These stationary objects are referred to as a frame of reference. What do you need to do in order to move this wheelbarrow uphill? That's right. You either need to push it or pull it. Similarly, these dogs are pulling this sled, and this snowplow is pushing snow. When an object, including a person, is pushed or pulled, it moves. Pulling and pushing are examples of forces. A force can cause an object to start moving, stop moving, or change direction. What force pulls this sled downhill, causes rain to fall to the ground, and pulls this ski jumper back to earth? Gravity. You decide. What is gravity? Gravity is the force that pulls objects toward the center of the earth. Gravity keeps us on Earth. If gravity didn't exist, when you jumped, you'd go flying off into space. Gravity is also the force which attracts planets to the sun and keeps them in orbit. Gravity can be measured in terms of the amount of force it exerts on a mass. Mass is the amount of matter or material in an object. The mass of this car is the same whether it's on Earth or the Moon. But on the Moon, the car has less weight. Weight is a measure of the force that gravity exerts on an object. The force of gravity is less on the Moon than on the Earth, causing objects to weigh less on the Moon than on the Earth. Why does this rolling ball eventually come to a stop? Why does this canoe slow down when the person stops paddling? And what allows these bugs to climb up and down this window? The answer lies in something called friction. Friction is a force that works against motion. Friction causes moving objects to slow down and eventually stop. Friction occurs where two objects touch, such as where the bottom of this box rubs against the floor, or where car tires meet the pavement. Without friction, our feet would not grip the ground. Friction enables rock climbers to climb cliffs. And friction enables this chameleon to cling to this swaying branch. Rough surfaces, such as the ground, tend to produce greater friction than smooth surfaces, such as ice. You compare. Does a road or a bumpy lawn create more friction for a bicycle? The bumpy lawn creates more friction for the bicycle rider than this smooth road, which makes bicycling easier. In many cases, friction can cause tremendous heat. Even friction created from rubbing your hands together produces heat. It's often necessary to reduce friction. For example, oil is used in car engines to reduce the friction between moving parts, allowing the engine to remain cooler. And wax is applied to the bottom of skis to help them glide better on the snow. In some cases, it's necessary to increase friction. Sand is often put on icy roads to help get better traction. And baseball players often wear gloves to help increase friction between their hands and the bat, enabling them to have better control. This baseball stays in motion until the player stops it in his glove. And these snowflakes keep falling downward until they hit the ground. This model rocket stays at rest until it's launched skyward. Inertia is the tendency of an object to stay in motion or to stay at rest until a force acts upon it. All objects, whether they're moving or at rest, have inertia. To start something moving or to stop something from moving, a force is needed to overcome inertia. Inertia is the reason why it's so important to wear seat belts. When a car is moving along and comes to a sudden stop, your body keeps moving forward due to inertia. The seat belt holds your body in place, thus preventing serious injuries. This powerboat is moving much faster than these train cars. How do you measure how fast something is going? Speed is a measure of the amount of distance covered per unit of time. Put another way, speed equals distance divided by time. For example, this sign warns drivers to limit their speed to 35 miles per hour. This means that they should not drive any faster than at a rate of 35 miles during 1 hour of driving. While speed can be measured in miles per hour, it can also be measured in metric units of kilometers per hour. For example, this helicopter can travel over 90 kilometers per hour. You compute. If a car travels 80 kilometers in 2 hours, what is its speed? The answer is computed by dividing 80 kilometers by 2 hours to get an answer of 40 kilometers per hour. Velocity is the speed of an object as well as the direction in which it's traveling. For example, the velocity of the water in this stream is 20 kilometers per hour north, and the velocity of this hot air balloon is 40 kilometers per hour southeast. You predict. What will happen when you push down on the gas pedal in this car? The car increases its speed or accelerates. You can feel a car accelerating, and you can see the result of acceleration by the moving needle of this speedometer. Acceleration is a change in velocity. Generally speaking, when the velocity of a moving object is increased, such as this rocket, it's referred to as a positive acceleration. Similarly, the person on this bicycle is positively accelerating down this hill. But acceleration can work the other way, or negatively. For example, when this skier turns his skis and slows down, he's negatively accelerating, as is this car when it stops for this stop sign. Deceleration is a term often used to describe a decrease in velocity. During the past few minutes, we've taken a look at many of the fascinating features of things in motion. We discussed how movement is visible due to frame of reference. And we took a look at how force starts an object moving or stops it. We looked at how the force of friction works against motion and how friction affects our everyday lives. Inertia is the tendency of an object to stay in motion or to stay at rest until a force acts upon it. We also described velocity as the speed of an object in a given direction. Finally, we discussed that acceleration is the change in velocity of an object. So, the next time you take a ride on a bike, throw a ball, or ride in a car, think about what we've talked about during the past few minutes. You just might think about things in motion a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. A push is a type of. Number 2. Is the force keeping us on Earth? Number 3. Causes objects to slow down. Number 4. Velocity is the of an object in a certain direction. And number 5. Describes a decrease in velocity.